So we're going to talk about the Hitchhiker's Guide to JavaScript, and there's no getting away from it. This is about JavaScript. Love it or hate it, it's about the language and the evolution of the language and the future of the language. Just to be safe, I'm going to include that. So I was working in the web for a long time, obviously using JavaScript, but ultimately not for very much more than a few jQuery plugins or image hovers or visual effects that I was doing with JavaScript. I wasn't building full-scale applications with it. That wasn't until my boss asked me if I would work with Financial Times on the Windows 8 application. You see, Windows 8 had a JavaScript native platform, so you could build native JavaScript applications using, native Windows applications using JavaScript, and they could do everything that regular Windows applications could do. We still have this capability in Windows 8, in Windows 10, and it means that you can use JavaScript to build native Windows applications, and the FT already had a very good HTML5 app, and so we were looking at porting it. So I was a little bit worried. I recognized that this was a very high-scale, sort of highly complex JavaScript application. I said to a friend that I used to work with, I don't know if I can do this with JavaScript. I don't know if I've got the capabilities or the skills to work with this kind of application. And he said to me, don't worry about that. You're really good at C#, Martin. And C# is a very similar syntax to Java. So how different can it be? Ultimately, JavaScript comes from Java, so they're very similar ideas. You'll be fine. You'll be right at home. I had to point out there that Java is to JavaScript as car is to carpet. They're very different kinds of languages. JavaScript being dynamic, it's a prototype inheritance language. Java's much more similar to sort of C# really than it is JavaScript. So I still was a little bit unsure, but gradually I started using the language and kind of evolved to like it a little bit more than I'd previously done. We started at Microsoft using it for lots of things. So the Xbox Music application, which is now Groove Music, that's all built in HTML and JavaScript. The entire application, hundreds of thousands of lines of code, all of that built in JavaScript. Visual Studio Online, which is an editor inside of the browser, that was the first instance of a thing called the Monaco editor. And this was fundamentally an IDE built in JavaScript. That Monaco editor, which is used in Visual Studio Online, also is included inside of the Edge dev tool. So if you press F12 inside of Microsoft Edge, the HTML portion, all of this stuff on there is all written in the Monaco editor. Actually, the rest of it, all of the thing that you see on screen with the F12 dev tools, all of that's written in JavaScript. And in fact, every browser who has dev tools, Google, Chrome, and Firefox, they all build their tools entirely in JavaScript. But you wouldn't notice when you first look at it that it's built in JavaScript. It looks very native-like. It looks very app-like. And then most recently, the Monaco editor became Visual Studio Code. So all of Visual Studio Code, everything you see on screen is written entirely in JavaScript. It's a huge JavaScript project. We don't actually write against JavaScript directly. It's actually written using TypeScript, which is compiled into JavaScript. But ultimately, everything you see on screen there is written and rendered by JavaScript. Now, I'd used it a little bit now in applications, but I hadn't really used it on server-side web applications. And that wasn't until a little project came along, which I'll talk about now. And it kind of shows me, through working on this project a little bit, I discovered that JavaScript is the future, and I have proof. So the website I was working on was dev.modern.ie. And dev.modern.ie, if we go to URL, so let's just have a look. I go to dev.modern.ie. It should forward me to the new URL. Oh, that won't work. It should be dev.modern.ie. Should forward me to the new URL, which is now developer.microsoft, and it's the Microsoft Edge developer portal. MicrosoftEdge.com, dev.microsoftedge.com, they'll all take you to the same place. But it's fundamentally a web portal, and there was a little tool in here called SiteScan. Now this scan, you can enter a URL, like bing.com, bing.com, and it will scan the site for issues, The problem with this is that this will only scan public sites, like sites which are on the public internet, because obviously the crawler, our little crawler, has to be able to go to the site. So we created an open source version of this. It's called the static code scan, and you can download it, execute it locally, and obviously then you can look at stuff which is maybe on localhost or on your local network or on your intranet. And basically it will scan the site and tell you if it's got issues with Microsoft Edge. So I was working on using this little application, and I was trying to show it and share it with a couple of customers and trying to improve their compatibility with Microsoft Edge. But I was finding it was very slow, and I wanted to try and improve it. I didn't know very much about Node at all, and because I'm a really, what's the word? I am a true believer in all of Microsoft's products. You know, I'm a complete convert to the Microsoft way. I didn't ask Stack Overflow why it was slow. Instead, I asked Cortana, and I said, "Hey Cortana, why is my how do I speed up my Node application?"
I've heard from a reliable source that the answer is 42.
And you see, I found out, you know, from her, it was a bit strange. What does this mean, answer 42? I don't really understand. But the thing you've got to understand about Node is that it all revolves around the package manager. So npm being the package manager. So I thought, okay, Node, npm, let's have a look at this then. So I went to my C drive, and somewhere in there is the code file. Open up there. And I said, okay, well, if the answer is 42, maybe it would be npm install answer 42. Well, I'll show you actually, before I do that, I'll just say node app.js. This will just load the application up first. See, it's starting slowly, running on port 1337 on localhost. So if I just go up there and say localhost 1337. That's the second time I've done that today. Sorry about that. HTTP localhost 1337. And if I do bing.com in here, you can scan it, and it will show you. It will basically. It doesn't create such a pretty report, but it basically creates a JSON representation of all the failing areas of that thing. So I thought, well, how do I speed this thing up? Okay, I'll say npm install answer 42. Okay. So it went over to npm, it installed that thing. Excellent. So now if I start up my application, node app.js, opening portal, wormhole open, firing up flux capacitor not installed, npm down, wormhole created, paradox detected, using AI to automatically publish to Azure. Don't panic, don't panic, don't panic. Actually, scrap that panic. Okay, this seems really strange. So now if I go back to the website and just refresh, oh my gosh. Something crazy's just happened. I somehow seem to have opened up a portal to another world. Let's see if we just move that off the screen for a second. It seems to actually be crashing my graphics card weirdly whilst I'm connecting to this this projector. Never mind. So it was strange that it was running like that. I Control C that. npm remove 42. Okay, we're back to normal. So what I did is I went to this folder here, and there's a folder called logs. And what I discovered was that whole thing, that portal which opened there, opened up a portal to 2020, and it put my site scanner live on the internet in the future. And then someone came along to my site, and then they scanned their current site with that little tool. And the companies that tried this thing and tested it was the BBC, the Hitchhiker's Guide to JavaScript, and the Sports Almanac 2016 to 2020. Now, the bbc.co.uk news site, there's not really much things, not very much which has happened really, which is worth mentioning. Actually, England is now called South Scotland, and Kanye West is president. But other than that, there's nothing else which was of merit, really. Hitchhiker's Guide to JavaScript, that shows about the future of JavaScript, and it's fundamentally what I'll be talking about for the rest of this talk. And then they've got the Sports Almanac 2016 to 2020. Every sports result for the last, over the next 4 years. I couldn't think of anything to do with that one, so I'll just go straight into the Hitchhiker's Guide to JavaScript application. Yeah, it's wonderful. This is the Hitchhiker's Guide to JavaScript from the future. And this is obviously the way of discovering about the future of JavaScript in 2020. So this is what all the web developers are using. Now, I can see what you might be thinking. The Hitchhiker's Guide to JavaScript.co.uk doesn't look particularly modern. It looks quite old-fashioned. If you think about it, one of the first websites, one of the first commercial websites was this one, Space Jam. Now, the thing is about web design is that it's cyclical. It's like a fashion, it's like trends. Things come and go. And 1996, that trend for kind of black backgrounds and weird GIFs, that's come back. And in 2020, most websites look like that. That's like the cool, new, long shadow, flat design of 2020. And if you're thinking, well, that's impossible, I can't imagine that style is ever going to come back, it's completely implausible. I want you to look at the current design leaders today and see the kind of work they're doing and see that it is pointing in the direction of this sort of thing. So really, most of the things that JavaScript, the Hitchhiker's Guide to the JavaScript speaks about in 2020 is ECMA. ECMA 2015 and how it changed the world. ECMA 2015 is a standard. It's sometimes called ECMA, ECMAScript 6 or ES6 or ES7 sometimes because it kind of melds into one. But ECMA 2015 is the language specification for JavaScript, the next version of JavaScript. And most of the things I'm going to show you here today are the things which are in this standard and which are kind of, by 2020, very much mainstream JavaScript practices. So let's go and have a look at what these sites are doing. Let's have a look. Right. So I'm just going to open up, go to my GitHub, documents, GitHub, that one. I'm just going to load this up in code. So if you're in a folder and you type code dot, it'll open up that folder inside of Visual Studio Code. If you have Visual Studio Code installed, obviously. And so let's have a look at what's in here. So one of the first things, one of the simplest things that the next version of JavaScript is going to allow us to do is to have default parameters. So at the moment, if you've got a function, you can accept parameters like x and y, of course. But what if someone chooses not to pass over the parameter y? Well, now we have the ability to set a default parameter. So if someone only calls the function with the parameter x in this instance, like they are here, they're calling f with 3, we are going to set the y to be a default parameter of 12, and so x plus y is going to be 15. If we chose to pass over a different number, 13 for example, then that would then return 16 because it would ignore the default parameter and accept the parameter which is passed in. But if someone doesn't pass the parameter, then that means that it will use the default version of it. It's called default parameters, common in other languages, not common currently in JavaScript, but it is in the next version. And in 2020, they're all using it. For loops. Let's imagine for a second that I have an array, and it has 3 values in it. 3, 5, and 7 is part of my array. So I've got an array with 3, 5, and 7. And then that object, that array object, also has a property of foo. which is set to a string called hello. Now, you might think, if I loop through that array and do a for in loop, because that's quite a common way of doing a for loop in JavaScript. There's a few different ways. You've got the traditional for loop, which is more like this, where you've got the index, and then index is greater than a particular array length, and then you've got the incrementer there as a third parameter, and then you loop through it that way. But you also have this thing, which is a for in loop, and you would assume that a for in loop would loop over the values, but it does not. A for in loop in JavaScript, oddly, loops over the properties of an object. So if we do a for in on the R array, instead of returning the values of the array, what it does instead is it logs the positions of the array, because we know that there's 3 elements in the array, so it logs 0, 1, 2, which are the indexes of the array, and then foo, because that's the property name, which is also on the array. It's kind of useful for certain scenarios, but not probably what we want to do. Now, because they don't want to change the behavior of for in to align it to the way that perhaps some other languages work with the for in loop, what they've done is added another additional sort of for loop called a for of loop, and that does behave in the way that you would expect a for in loop to work. So for of array now logs, instead of logging 0, 1, 2, it logs 3, 5, and 7, which are the values of the array, as you'd expect. Quite a common thing inside of when someone's looking at ECMAScript 6 or ECMA 2015, as it's also called, is that they'll see the new ways that we can declare variables. So in JavaScript today, you're pretty much restricted to var I equals, say, a number. And var, you var all the things. Everything's a var. What we're able to do now is also require or use let. So we can say let x, and it's exactly the same as var x, except it's scoped. So when you declare x in this scope, which is basically in JavaScript, a scope is the parentheses, these not parentheses, sorry, these these brackets. Anything inside of this bracket is the, or not inside of another bracket, is this scope. So let is now declared in this outer scope here, but we can create then another inner scope inside of this thing here. Maybe we're calling a function like this. Oops. An anonymous function, or oops. Or could I just take it like that? I don't know. Forget it. Let's just say I've got another block scope just here. Sorry, and now we're declaring a const inside of here called x. Now these are 2 different variables, effectively, because they're in 2 different scopes. We've got the x which is outside, and then the x which is inside. We've also declared this one a const. And that's another new way of creating a variable which creates a constant. So I can't then go and change the value of x. Well, my editor is going to actually allow me. It's not going to red underline squiggly it. I don't know why, because it was doing that a few weeks ago. But recently it's not been red underline squiggly when I make an error to a const. But when I actually do run this application, it will immediately error and say that I can't, inside of a browser, and say you can't reassign a const variable. So it's useful for things like, I don't know, parameters or strings which are not going to change throughout the lifecycle of the application. You want to explicitly say that this should never change inside of the lifecycle of the application. So we've got a few new ways of declaring variables. You've got let, which is all about the scope of the variable, and const, which is creating variables which should not change throughout the application. Next we have REST. And it's a kind of a REST pattern of dealing with or passing parameters to functions. Now imagine we have excuse me, a function called f here, and it accepts a parameter of x, and then it accepts a parameter called y, but it's got this weird ... notation in it as well. Now this ... notation says anything after the first parameter, I want you to enclose or include or create an array of all of those parameters, and I want to keep it in an array called y. So in previous JavaScript, if I'd have said just x and y like this, x would be 3, and y would be hello, and true would just be lost. But now if I do dot, 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 what will happen? X will be 3 and Y will be an array containing hello and true. So if I take X and Y and I do a for of loop over Y and I log this out, I would get hello and true because the items inside of Y are hello and true. And Y is just this an array. It's a very convenient way of dealing with the parameters that were passed in. And it's a good sort of catch-all. It's rather than having a huge signature for your function, you can just have this parameter which accepts anything, basically. The inverse of that is a thing called spread. Let's say that you have an array, existing array, and you want to pass that into a function, but that function has a signature which expects 3 parameters. It expects X, Y, and Z. Well, you have an array with 3 elements in it, so what you want to do is you want to spread that array out across that function. And the way you do that is you use the syntax of dot, 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 the array, and you pass it into the function, and it will spread that array out so that the position 0 of that array will go to X, position 1 of that array will go to Y, and position 2 of that array will go to Z. So that's kind of, and all I'm doing here is X plus Y plus Z, so 1 plus 2 plus 3 equals 6 will be the output of that function. So it's kind of like the opposite of spread. Now, excuse me for coughing there. This is a slightly odd thing about the future of JavaScript. A lot of JavaScript files in the future look like this. You see, this line here, this is perfectly valid JavaScript today, and I suggest that you all do this today. I think that this is a fantastic sort of way of developing JavaScript. Having variables with like funny eyes with a little mouth equals the number 42. But the other stuff underneath it, this is not valid JavaScript. This rocket ship is sadly not valid JavaScript. And that's because the JavaScript specification has a certain number of, or certain Unicode points that it supports and certain Unicode points that it does not support. And what we've seen gradually is that as JavaScript's evolved, it's including more Unicode points into, so it will be possible probably in the future that it will have a full support of Unicode, to which point then you can include all of these different emoji Unicode symbols anywhere inside of your application and create quite beautiful, illustrative JavaScript. Now you might be thinking, emoji? Why would anyone be using emoji? Well, it's big business in the future. And just to explain that, this is the Lucky Golden Poo. And just to explain that emoji is quite serious today, I'm going to tell you a story of the Lucky Golden Poo. So the Unicode definition of that code point, the Lucky Golden Poo, is a pile of feces. But that doesn't look very much like a pile of feces. That looks more like some soft serve with eyes and a mouth. This is from Windows. This is our version of that Unicode point. So if you put that emoji into a message and you send it to a Windows phone or a Windows device from an iPhone, because this is the iPhone's or the Apple version of that code point, you will receive this on your Windows phone. That's the code point interpretation that we have for that Unicode definition, that point. So someone in 2012 actually reported this as a bug to our design team on Internet Explorer. And this is the genuine bug report which has come through. It says, poop emoji does not have a smiley face. And I love this response. It says, the significance of the smile for Lucky Golden Poo, yes, it's a real thing. We left out the smile because the Unicode description did not indicate that the code point represents Lucky Golden Poo. Incidentally, we also explored variations with flies around it and steam vapors. But we concluded, in the end, that to keep our interpretation literal and true to the Unicode description, as we tried to do with all of the other characters. Emoji serious. Unicode is serious. And in 2020, it's very serious. And that Lucky Golden Poo stuff is just amazing. And I know what you're thinking. What do all the other technical companies do with that emoji, that Unicode point? Well, Twitter, you see, they have a very similar thing to what Apple have. They have like a more flat designed, it looks like an ice cream top, with eyes and a smile. Google, they've got a pile of feces, very much a pile of feces, but this time without the eyes and without the mouth, and with flies around it and sort of vapors coming out. So they actually went with the version which the design team at Microsoft sort of excluded. And then you've got Facebook, which is really weird. It doesn't have any mouth, and it has some eyes, just the eyes. I think this is the strangest of all, because everybody I know on Facebook talks poo. So why they don't have a mouth, I do not understand. Excuse me. So now we have the emoji will be supported in 2020. The other thing which we'll see in ECMAScript is kind of the support for classes. And this is probably the canonical example when people talk about ECMAScript 2015, is that it has classes support. So if we look at that, this is a piece of JavaScript from a traditional piece of JavaScript, actually from a knockout application. We've got an app view model, and it calls an anonymous function. Excuse me. So the app view model becomes kind of like a class. It's actually a function, but it appears to have properties. You can new it up. You can create this thing, and it has some methods on it, and so forth. It looks sort of like a class, but this is how you would construct a class in traditional JavaScript. So the new version, the new way of writing that exact same piece of code, and ultimately it compiles down to the exact same thing, is this. We have a class decorator, a class name. It's got a constructor. We have properties. We've got this chosen selector this month. We've got an anonymous function. You'll see this thing appear quite often. This symbol. This symbol is a if you're a C# developer, you might know it as a lambda. Some people call it a fat arrow, and it's basically the same as writing. Let me write underneath it. ko.computed, and then that was going to pass in a function like that. So that syntax is equivalent to this syntax here. And what that means is that excuse me, or roughly equivalent to that. So what that means is that we've basically, with the new syntax, we've kind of cleaned up the way that JavaScript looks. So it has these anonymous functions and so forth. There are some other benefits of anonymous functions like this. You'll see that it has a this reference, this dot refresh data. Now, if I actually in this anonymous function called the same function, this dot refresh data, depending on how you call this function, this might not actually be the this that you're expecting. You'd expect it to be referencing this, like the thing which it belongs to. But actually, when you're calling an anonymous function, this will depend very much on how the function has been actually executed and acquired. So it also cleans up a problem, a very common problem with JavaScript, where this means something in different contexts. Whereas the this, which is included after a lambda, is always the same context as anything else outside it as well. We're also using a few other things inside of this class, which are new. This is a URL variable. Now, traditionally in JavaScript, you might see something like this. So that's how you would concatenate a string. They have this new syntax, which is using this particular character called a backtick. If I zoom in a little bit, you can see it. A backtick, it's just on a Windows keyboard. It's usually just next to the character 1, the 1 character. On a Mac, it's just above the control character on the keyboard, and it basically is, in JavaScript, it means that we can then have this syntax where you put in the middle of a string, which has been declared inside of a backtick, you can say $, and then that opening parentheses or bracket, sorry, and then the variable name, and then a closing bracket, and it will do a string concatenation. There's also one other usefulness for this. You can actually have a string which spans multiple lines, which you can't do with a regular kind of string variable as well. So that's what that syntax means. and those things are called backticks. And this is a new feature, actually. It's inside of Chrome, and it's also inside of Edge at the moment, and probably Mozilla, but I don't Firefox, but I'm not completely sure. And this is a new API. There's lots of new browser APIs. So we've had we're requesting or getting JSON in the same sort of way using XML document stuff for a long time. We now have a fetch API, which is promise-based. So we can call fetch, pass a URL to it. It will basically call that URL, and whatever response it gets, it will then pass into the promise. And promises in JavaScript, by the way, are this kind of this dot then sort of structure, which I won't go into right now. But fundamentally, those are the things that I learned about the way that JavaScript works. Now, lots of those features and stuff that you might want to use them today, but you want to also write websites that work in every browser. Now, Chrome and Edge and Firefox all have pretty good support on their nightly builds and their latest builds of their browser for these features. All of those features you could probably use today if your users only ever use the latest browser. But if you want to make it compatible so that you can code in this new stuff, but it will work in older browsers, then you'll need to use a thing called a transpiler. And there's lots of transpilers out there. TypeScript, you might have heard of, is a sort of transpiler. There's Babel.js, which is a transpiler as well. This website, canjax.github.io/compat-table/ES6. It lists all of the compilers and shows you their current level of support, and it also shows you all of the browsers' current level of support of ECMA 2015 too. The other thing that they're doing in 2020 is they are compiling JavaScript into things called asm.js and WebAssembly. What this is, it's a subset of JavaScript. Asm.js is a subset of JavaScript that uses known types. There's no just-in-time compiler. There's errors. There's no garbage collection. Fundamentally, it takes JavaScript. It's a way of writing JavaScript which can make it extremely fast. And we can also take languages like C++ and convert them using asm.js into JavaScript. So someone might originally write the code in C++, then convert it using asm.js into C++. At the moment, you can then take an asm.js file, the output of the C++ compiled stuff, into asm.js, and then convert it into a thing called WebAssembly. I imagine that there'll be very shortly there'll be ways of taking directly your C++ and converting it directly into WebAssembly, but you currently have this asm.js step. What this means is that people are currently writing C++, like they're writing games, engines, and so forth, and then they're very easily converting that thing into JavaScript. And what this is creating is a very strange world in which JavaScript is kind of like the virtual machine in which you're executing potentially other languages. Another feature is a thing called SIMD. It was implemented by Intel inside of Microsoft Edge, and it's also been implemented in Chrome, I believe, now. And it means that you can take advantage of some of the abilities of modern processors to parallelize operations. So you can do you can do mathematics at the same sort of time. That you can add the CPU can add things up or take multiple instructions on I'm not explaining this very well, but it can do single instruction, multiple data, and it can basically speed up operations of CPU, and you can get more power out of the CPU by using SIMD. This is very useful for people which are developing games and people which want to get really raw performance. By combining things like asm.js and WebAssembly and SIMD, what we're getting to is the point where JavaScript can run at very similar speeds to natives like C++ on a machine. And so what we'll start to see is JavaScript moving to native speeds. And you'll start to see things like people compiling C++ to JavaScript to then execute in the browser at the same sorts of speeds as C++. But it potentially as well, managed languages could be done. This could be done to managed languages as well, where you'd take a managed language like .NET or Java and convert it into some form of WebAssembly and then execute it in the browser in JavaScript. But you actually write it in something very different. So that's it from me. I just wanted to say this is kind of JavaScript, the future of JavaScript. There's an awful lot of potential in this language, and we might be writing more modern JavaScript with the stuff which is in ECMA 2015. And in fact, we might not even be writing JavaScript at all but we will be executing JavaScript using things like WebAssembly as well. So that was the future of JavaScript.